let's go over problem 11 of the SOA sample questions for exam P. So this is more of an algebra problem, so it's actually pretty simple. So let's go ahead and read the question. An actuary is studying the insurance preferences of automobile owners and makes the following conclusions. An automobile owner is twice as likely to purchase collision coverage as disability coverage. The event that an automobile owner purchases collision coverage is independent of the event that he or she purchases disability coverage. And the probability that an automobile owner purchases both collision and disability coverages is 0.15. What is the probability that an automobile owner purchases neither collision nor disability coverage? So the first thing I think we should do is define point 1. An automobile owner is twice as likely to purchase collision coverage as disability coverage. So I'm going to denote C as collision and D as disability. So let's see. The probability that someone purchases collision is equal to 2 times the probability that someone purchases disability. Okay? Now that's done. I think we should now go to point 3, which is the probability that an automobile owner purchases both collision and disability coverages is 0.15. So this is where the algebra starts coming in. So if you remember, the probability of an intersection for independent events, so let's write out the equation. So the probability of C intersection D, because we're calculating the probability that someone purchases both collision and disability at the same time, is equal to 0.15. But we'll get to that. So with the rule of independence, it's going to be probability of C times probability of D. Now, luckily, we already predefined what probability of C is, which is 2 times probability D. So this is going to equal probability of D times probability of D times 2, because we are filling in the fact that the probability of C is 2 times PD. Okay? So let's clean this up a little bit. So this is going to be 2 times probability of D squared, which is all equal to 0.15. Okay, and now all we do is solve for probability D. So doing a little bit of algebra, so 0.15 divided by 2, and then the square root of that answer is going to be, so we'll make the probability of D equal to 0.27, and I'm going to round this last digit to 4. And from this, we can calculate what the probability of C is. So we reinsert the probability of D into our definition up here for 0.1, and that's going to equal to 0.548. Okay. Now, we want to calculate what is the probability that an automobile owner purchases neither collision nor disability coverage. So that means that even if an automobile owner is going to purchase coverage, it's not going to be collision or it's not going to be disability coverage. So what does that mean? That's going to mean the answer is going to be this formula of 1 minus the probability of C union D. So what is the definition of probability of C union D? It is the, let's write this down. Probability of C union D is equal to the probability of C plus the probability of D minus the probability of C intersection D. Okay, we have our formula now. So let's solve for this part of the equation, the probability of C union D. So if we just add in or replace all these individual parts, so the probability C, the probability D, and the probability of C intersection D, we will get, so the probability of C union D is equal to 0.548 plus 0.274 minus 0.15. And that's going to equal 0.672. Okay, now we're going to solve for the ultimate equation for what the question was asking, which is the probability that an owner does not purchase either collision or disability, which is this equation. So we're going to take this 1 minus 0.672 which is going to be 0.328. And because rounding, it's going to be somewhat close, but not exactly to matching one of the answer choices. But I'm going to choose answer B because it is the closest out of all of our choices. And if we kind of like used more decimal places, we can kind of get to a more exact answer. But there are kind of rounding rules in these exams, and be really careful. But I think if you go to the third decimal place, you should be fine. So the answer choice is B, which is 0.33, and that's how you solve problem 11. If you like this video or if you like the explanation, please leave a like. If you have any kind of suggestions or questions about the question, please leave a comment. All right, thanks.